This is John with lesson 5 for year 13 physics, and this one is about impedance in a resistor capacitor series circuit where the supply is an AC supply. So when a resistor and a capacitor are connected in series in an AC circuit, the combined effect of resistance and reactance will limit the circuit current, and this current limiting effect is called impedance. Now the voltage equations are VR is IR, VC is IXC, and VS is IZ. Now you can draw a voltage phasor diagram because that's your VR, that's your VC, and that's your VS. So VS squared is VR squared plus VC squared. Now in place of VS, I'm going to put IZ. So you get IZ whole squared, and instead of VR I get IR whole squared, and instead of VC I get IXC whole squared. Now I is a common factor, so you're left with Z squared is R squared plus XC squared, or Z is square root of R squared plus XC squared. So we can also draw an impedance phasor diagram. So you get your resistance along here horizontally, that's your XC, and when you add them vectorially, that's your Z, which is the impedance. How do you calculate XC? By using 1 over 2 pi FC. Now just remember, the circuit current is always in phase with the voltage across the resistor. Also an important thing to note, when you're drawing phasor diagrams, all the physical quantities need to be the same. You can't mix them up. So you can have a voltage phasor diagram where you have all voltages, or you can have an impedance phasor diagram where you have resistance and reactance and impedance. Okay, you cannot have a voltage value here in the middle of all the resistance or reactance values. Now here's an example. So I've got, first of all, to find the value of R and XC and then the combined effect. So this is an AC circuit with just a pure resistor. I've been given the value of the supply voltage and current. I've used Ohm's law, and I've got the resistance. Next step, the capacitor, the size of the current is given. So I get XC. I've got to find out XC, which is Vs over I, and I get the value for the reactance of the capacitor. Now that I know the reactance of the resistance of the resistor and reactance of the capacitor, I can combine both of them to get my impedance, and they need to be added using Pythagoras. Okay, now there are some questions on Ohm's law which I have done, and you're most welcome to take a look to check your own answers. And remember, you don't mix up voltage and impedance phasor diagrams. They need to be kept separately. And remember, the current is always in phase with the resistor, so your supply voltage will always lag the current, or your current will lead the supply voltage. So here's another question, and then there's one more over here.